many moles of H2O2 is present in 93.0 milliliters of 0.500 molar H2O2. Okay, so the first thing I'm going to do is identify what I've been given. I have 93.0 milliliters of H2O2 solution, and that solution is 0.500 molar H2O2. Anytime I see a concentration unit, one of the first things I do is I rewrite that concentration unit so that it illustrates all of its units. So I rewrite this 0.500 molar H2O2 to represent 0.500 moles of H2O2 per 1 liter. By doing so, you'll see concentration units actually consist of more than one unit. And therefore, when we're choosing what to begin our calculation with, the 93.0 milliliters of solution or the 0.500 molar of H2O2, it makes it a little easier because ideally you're going to start the calculation with something that has only one unit associated with it. So we will start our calculation with the 93.0 milliliters of solution and be converting that into moles of H2O2. Now, if you look here, we have a volume and we have a moles. Anytime you have moles and volume, the conversion factor is typically going to be that of molarity. But in order to use our molarity, our volume unit has to be converted so that it matches the volume unit within the molarity. So we're going to take this 93.0 milliliters, and the first thing we're going to have to do is convert that into liters. There's 1,000 milliliters in 1 liter. The milliliters of solution will cancel, leaving liters of solution. Now that it is in liters of solution, we can now use the molarity to convert between volume and moles. The liter of solution from the molarity will go into the denominator, while the 0.500 moles of H2O2 go into the numerator. The liters of solution were placed in the denominator so that the substance in the unit can cancel out, and you're left with moles of H2O2. Since that is what we wanted to calculate, we are now ready to key this into our calculator. So you have 93.0 divided by 1,000 times 0.500 means you have a value of 0.0465 moles of H2O2. You should always give your answer to the correct number of significant digits. This is multiplication and division, and according to the rules of multiplication and division, your answer will have the same number of significant digits as the measurement with the fewest. 93.0 has 3 significant digits because zeros at the end of the number after the decimal are significant. The 1 liter of solution from the metric prefix conversion is an exact number with an unlimited number of significant digits. The 1,000 milliliters of solution from the metric prefix system is also an exact number with an unlimited number of significant digits. The 0.500 moles of H2O2 has 3 significant digits because zeros at the end of a number after a decimal are significant. And the 1 liter of solution from the molarity is an exact number, and therefore it has an unlimited number of significant digits. So we have 3 significant digits times an unlimited number of significant digits divided by an unlimited number of significant digits times 3 significant digits divided by an unlimited number of significant digits. Since the measurement with the fewest had 3 significant digits, your answer should have 3 significant digits, so we would indeed record the answer as 0.0465 moles of H2O2.